operation here allow you to downsampling, work at low rate, but still retain exactly your original signal. It's right here. Okay? It's right there. Right? So let's look at the rate. If my sampling frequency here, suppose this is 1 megahertz, let's say 2 megahertz. What is the resulting rate here? 1 megahertz. And here? 1 megahertz. So that's good, right? We are changing the rate now. We are decomposing a 2 megahertz signal, a high bandwidth signal, into 1 megahertz signal, which is fine. Okay? Now, what application do we need this for? Why do we bother to talk about multi-rate DSP? So I'm just asking you, why do you see this before? Okay, let's play with DSP. That's I don't know. So okay. Who use MP3? MP3, sound audio compression format. You listen to MP3 song already, right? Okay. How does MP3 work? First is take the signal, right? It actually to the field wave. It takes a audio signal. So I've looked at a typical spectrum of an audio signal. What does it look like? Highly low frequency, right? Does it have some low frequency? What happens at high frequency? It's very, very small, okay? So it could be, if we look at a magnitude, it could be something like that. Okay? Very low frequency out here. Now, if you want to compress the signal or save it, what's the best way to do this? What if I divide this into multi-band? Okay, and so on. And depends on the energy of this band. I can allocate the bit, right, to this band. The band will have higher energy. I can give more bits to them, and so on. Okay, so that's the basic idea of compression. Later on, when Professor Scott will discuss compression, you will see that it is basically a transform. This can be viewed as a transform. Okay? And then the transform is basically going from high rate to multiple low rate. This example from 2 to 2 of 1. But in MP3, you have going from 16 to 16 multiple of 1. Okay? But the same idea is here. You can have downsampling by 16. This will be low pass, band pass, and then the high pass. So what I'm drawing here is the frequency response of those filters. Okay? And we're using downsampling to keep the same rate, right? A transformation is not useful if we're going from, suppose I have no downsampling here. What happens? I have 2 megahertz, 2 megahertz, 2 megahertz, that's 4 megahertz. It's not useful in compression. You don't want to deal with 4 megahertz. You are expanding, right? You don't want to do that. You want to keep from 2 megahertz to 2 megahertz. So you have to have this downsampling. Okay? But the way that we do it here is we are manipulating the frequency, the spectrum of the signal through transform, right? And therefore after this step, you will allocate certain bit to certain spectrum that have higher energy. So that's one application. in compression. 32 users, okay? So you have user X1, X2, X of 32. In a particular cell, right? Each of them, let's say, 8 kilohertz spectrum. Right? You have a particular bandwidth for your speech. Okay? And what do you have here? You have your friend, right? That you talk to. Okay? This is Y1, Y2, Y32. What is in between? How do I get in this particular cell when you have 32 users at one time? How do we send all this to a particular cell, chunk of frequency over the other end? What goes on in here? You have to combine this together, right, into a signal when you send over to the base station. What is that spectrum? What is the bandwidth? 8 times 32, which is what? What's 8 times 32? 256, right? And then the base station has to do this. Okay? So what are the steps that going from 8 to 32? Upsampling. What are the steps that going from 32 to 256 to... So you see that in GSM network, you're actually doing upsampling and downsampling. Okay, so how do I do upsampling? How do I combine them together? You have to have the up by 32, right? And then you want to have a filter here. H1, H2 to H32. But this filter, this is low pass, band pass, and so on. This filter basically modulates the spectrum, right? So you have here 8 kilohertz. After this, it is 256. And the filter basically just save that particular area. So this one is here, if this is that signal, this is that signal, and this one, that signal. And what happened is that, go through this process, when you combine this together, okay, add together, this spectrum, low frequency, we have this guy, next one will be here, and the last guy will be like that. That's what happened, right? Because this is 256 kilohertz. Each of them is 8. We have 8 times 32 is 256. So the way you combine spectrum, low bandwidth spectrum into high bandwidth spectrum, is through a process of interpolation, where the choice of the filter will be where you want to place the spectrum. Okay? Is that clear? Yes. What is the order process? Now you receive this spectrum. How do you assign this to here? It's downsample, right? It will be first filter this and then extract them out. Okay, so we have let's go F1 and now by 32. And that's F1 benefit to pi by 32, just look at this thing, and so on. Right? And it's going to be F2 now by 32, and so on. Now cable network is very similar to this, right? The pipe that goes to your house have all the channels. This is how your decoder works.